Hello student, good morning. I am Dr.A.K. Now I am going to start new chapter thermodynamics. This chapter is very important and very conceptual, and your concentration is required. You have to understand it. Listen carefully. Chemical energy stored by molecules can be replaced as heat during chemical reactions. When a fuel like methane, cooking gas, or coal burnings in air, chemical energy stored by molecules can be released as heat during chemical reaction. When a fuel like methane, cooking gas, or coal burns in air, the chemical energy may also be used to do mechanical work when a fuel burns in an engine, or to provide electrical energy through a galvanic cell like a dry cell. Thus, various forms of energy are interrelated, and under certain conditions these may be transferred from one form into another. The study of these energy transformation, this you have to understand. The study of these energy transformation from the subject matter of thermodynamics. This is the important thing. The study of these energy transformations forms the subject matter of thermodynamics. Thermodynamics, my name itself is there, therm plus dynamics, means here in a simple way you can tell flow of heat, flow of energy, or flow of heat. Dynamics means movement. Dynamics, thermodynamics means heat flow. That is the meaning of thermodynamics. Now, this I have told that a study of these energy transposition, various type of energies are there and all are interrelated. The study of this energy transformation forms the subject matter of thermodynamics. The laws of thermodynamics deal with energy change of macroscopic system involving a large number of molecules rather than macroscopic systems containing few molecules. It is not applied for macro, MIC, means for few molecules it will not apply. It will apply only for macro, MAC, means large number of molecules. Thermodynamics is not concerned about how and at what rate these energy transformations are carried out, but it is based on the initial and final state of a system undergoing the change. This thermodynamics is not related to the rate means how and at what rate these energy transformations are carried out. Is not related to that. Okay, then it is related only to the initial and final state. It is based on initial and final state of a system undergoing the change. Laws of thermodynamics apply only when a system is in equilibrium. This is a condition. Laws of thermodynamics apply only when a system is in equilibrium or moves from one equilibrium state to the another equilibrium state. Macroscopic properties. What are the macroscopic properties? The macroscopic MAC, macroscopic properties like pressure, temperature do not change with time. It will not change with time for a system in equilibrium. If they are in equilibrium, then they will not change with the time. Okay, it will change only when equilibrium will be disturbed. Then macroscopic properties like pressure, temperature do not change with time for a system in equilibrium state. Okay. Then now here in this in the thermodynamics, what answer you will get, then answer of what type of question, I am doing some questions, you will get answer only by thermodynamics, a study of thermodynamics. As for example, that how do we determine the energy change? How do we determine the energy change involved in a chemical reaction or chemical process? Will it occur or not? Reaction will occur or not? This answer of this question you will find. Means how do we determine the energy change? In a reaction, energy change will take place. Then how do we determine the energy change involved in a chemical reaction? Then that answer we will get. Another question, what drives a chemical reaction or process? Means how chemical reactions are going on. What drives a chemical reaction? That answer you will get from thermodynamics. Another question, to what extent do the chemical reaction proceed? If chemical reactions are going on, then it will go up to what level, up to what extent? That answer you will get from thermodynamics. Okay, thermodynamics will respond you many answer of the questions. Okay, now I will tell you some thermodynamics terms which we should know. Then first term is the system and the surroundings. These are the very, very important terms, starting point. Thermodynamic terms. Then what is the system and the surroundings? First you understand. A system in thermodynamics refers to that part of the universe in which observations are made and remaining universe constitute the surroundings. The surroundings include everything other than the system. System and surroundings together constitute the universe. In a simple way, what you are considering, that is the system, rest things are universe. As for example, suppose you are in college and your classes are going on, you are focusing only on board, blackboard or whiteboard, then that whiteboard is system and remaining other things are called surroundings. What you are thinking, suppose in a lab you are considering in a beaker, suppose solutions are there, solution is kept in a beaker, you are seeing that solution only, then that solution kept in beaker or complete beaker, you can tell where you are considering, that is the system, and other remaining things are called surroundings. Very simple way, what you are considering, that is the system, other things are surroundings. And both if you will add system plus surrounding, then that is called inverse. Very simple. What you are considering? If you are considering only Bangalore, then Bangalore is a system, and other things, other parts are called surroundings. Means your consideration. If test tube we are considering only test tube. In that some solutions are there in test tube. Then test tube is the system, and other things, remaining things are called surroundings. I have given so much example. I think you might have understood. Okay. The inverse means inverse is equal to the system plus the surroundings. The inverse is equal to the system plus the surroundings. Very simple way. However, the entire inverse other than the system is not affected by the change taking place in the system. This is important. You are considering only system. If any things are going on, means the entire universe other than the system is not affected by the change taking place in the system. What you are doing only there, it will not affect the surroundings. Therefore, for all practical purposes, the surroundings are that portion of the remaining universe which can interact with the system. Usually, the region of space in the neighborhood of the system constitute the surroundings. Okay, then there are two parts, system and surroundings. Then here in system and surrounding, then some possibility is there that two things are there, matter and energy. If any change is going on, then suppose during the reaction, chemical reaction, evaporation, effervescence will take place, means some gas will come with some heat. Some reactions are going on in a test tube. Then you have seen that fumes are coming, red fumes, blue fumes, like that. Some fumes will come, white fumes, and some heat may also produce. Then these two things from the test tube, it will go to the outside, means to the surroundings. This is possible. Then fumes is considered as a matter, and heat is considered as a energy. Okay, these two things you keep in mind for further understanding. Okay. Now another example I am going. For example, if we are studying the reaction between two substances A and B kept in a beaker, the beaker containing the reaction mixture is the system. The beaker containing the reaction mixture is the system, and the room where the beaker is kept is the surroundings. Okay. This you can imagine in your mind. That is sufficient. Now here again is important that the system may be defined by physical boundaries. Okay, like beaker or test tube, or the system may be simply be defined by a set of Cartesian coordinates specifying a particular volume in a space. Actually, I will send some diagram, then you may understand that beaker. Then you have kept a beaker. Then beaker itself only is a system, just like a boundary. You can limit. After that, other things are there. Then just what you are considering just like a blackboard. Then blackboard is just like outer border is just like a boundary. After that surrounding will start. Board that you have seen, blackboard or whiteboard, then this outermost part, that is the limit. that is a limit boundary. After that walls will start, then that is called boundary. Okay. Then here in any system and surroundings, one you can give a limit that up to this system is there, after that surrounding will be there. Okay. Then here the system may be defined by the physical boundary. After that surrounding will start. The beaker or test tube or the system may simply be defined by a set of Cartesian coordinates specifying a particular volume in a space, means length, breadth, height, that suppose you are considering. In a space you are considering up to what length you are considering, what is the height, length, breadth, height, that only you can put a line. You put a line up to this is the system, after that surroundings. Then this I have told about the physical boundaries. Now it is necessary to think of the system as separated from the surroundings by some sort of wall, which may be real or imaginary. Sometimes imaginary also you can think, real or imaginary. The wall that separates the system from the surrounding is called boundary. Okay, this is just like a border. After that, after just like India border, it is with China or Pakistan, like that type of situations are there. Boundary. Then here a small it will apply for a small portion also, like for test tube, beaker, board, or any other thing which you are considering, that is the system. Okay, I think you have understood. Then this boundary, this is called boundary. The wall that separates the system from the surrounding is called the boundary. This is designated to allow us to control and keep track of all movement of matters and energy in or out of the system. Okay, this by this boundary only you can tell that or we can keep track of all the movements of matter and energy in or out of the system. Now types of system. Now second term, types of system. This is very, very important, and in examination it is also asked. It is conceptual. Okay, types of system. Then we can classify systems according to the movement of matter and energy in or out of the system. Okay. Open system. There are three systems. Open system, and second is the closed system, and third is the isolated system. One by one, just to understand. Open system. Here I want to tell you, it is very easy to understand. In the beginning I told you that matter and energy can go from system to surrounding, sometimes from surrounding to system. Both are possible. From system to surrounding or from surrounding to system, both are possible. Then what they will transfer? Then two things only they will transfer, either matter or energy. Sometimes only matter, sometimes only energy, sometimes both. Then now according to this, it is classified into three systems: open system, closed system, isolated system. Then now open system, try to understand. It is very easy. In an open system, there is a exchange of energy and matter, both. That's why name is open. In open system, there is a exchange of energy and matter between system and surroundings. Means it can go to the surrounding, from the surrounding also it can come to the system. Okay, the the presence of reactants in open beaker. The presence of reactants in an open beaker is an example of an open system. Here the boundary is an imaginary surface enclosing the beaker and reactants. Beaker and reactants. When the reaction will take place, then whatever will come out, either fumes or heat, it will go out of beaker. Out of beaker. Both can go. That's why open system means exchange of energy and matter between system and surroundings. Keep in mind. Now second is the closed system. Here you can say name is a closed, means it is not free, not open, closed. Then here it is closed for what? In a closed system there is a no exchange of matter. Only energy can exchange, not the matter. That's why closed. In a closed system there is a no exchange of matter. Matter is bigger, na? Heat can flow, but matter can't flow. Then in a open system there is a no exchange of matter, but exchange of energy is possible between system and surroundings. Okay, this is the simple. I have to, it is very easy to understand. The presence of reactants in a closed vessel made up of conducting material, as for example copper or steel, is an example of closed vessel. Closed vessel. Then you know that the if vessel is made up of copper or steel, then copper is the conducting material. Means heat can pass through a steel, heat can pass through the this copper. Then heat is passing, but gas and other things, gas, precipitate, anything that will be inside the container also. It is a closed, from everywhere it is closed. And suppose that is made up of from conducting material like copper, steel, aluminum. And this is the example I have told you. Then this is called closed system. Okay, only energy, heat energy or energy can transfer to the surrounding, or from the surrounding it can enter the system, but not the matter. This is the closed system. Means here again I am telling you, in closed system there is no exchange of matter, but exchange of energy is possible between system and the surroundings. Okay, now come to the third, isolated system. In an isolated system there is a no exchange of energy or matter between the system and the surroundings. Fully reserved. Neither in the name itself is there, isolated, just like you have seen in corona period. People, patient were isolated, they were kept in isolated, and nobody can meet him. Neither he can meet to anybody, other person can't meet. Like same situation is there. Isolated system means here no, in an isolated system there is a no exchange of energy or matter, both can't exchange between the system and the surroundings. The presence of reactants in a thermos flask is a very good example. The presence of reactants in thermos flask or any other closed insulated vessel is an example of an isolated system. In flask, do you know that heat will also not come out? Means in energy is also, heat energy is also, heat is also energy. Energy is of many types: chemical energy, electrical energy, mechanical energy, sound energy, light energy, all are energy, heat energy. Then whatever be, you know that in a flask heat will not come out, correct? Vapor will also not come out. Then that is the best example of isolated system. Today is the first day for thermodynamics. I am stopping only here. Next class again I will discuss. Okay, we will meet. Thank you.